So thanks all for coming back. Really, I think that there's going to be a lot of information shared, a lot of things we have to think about, and hopefully we'll have enough time for panel discussion. I can already say it's probably one of the best panels I've been to, and so you guys have really set a precedent. And we're going to now have Andre Chow, who's come all the way from London, who represents touch surgery, and I think it's something that I'd like the ACGME to think about is how can we incorporate these paradigms for future training, and that's why I've introduced him and is combining these topics in the panel. So Andre?
Thank you so much for having me. I've got to say I'm really honored to be speaking to you all today, to be part of such an esteemed panel. Thank you. It's a real pleasure, and thank you, Aaron and Lorraine, actually, for inviting me over. My name's Andre Chow. I'm a former general surgical trainee from London. I did most of my training in St Mary's Hospital in Paddington, and I went to Imperial College Medical School, graduated in 2004, and probably spent about 9 years in the training program. I took a bit of time out to do a PhD in something completely unrelated, which is, I know, as PhDs go. And in about 2013, I basically stepped back from clinical training to work full-time on a project called Touch Surgery, which I'm hopefully going to tell you a bit about today. And really, I guess where it starts is with my experiences in training. It wasn't all like this, obviously. But as a trainee in London, I think I got to experience firsthand a lot of the problems that affected not only me, but probably a lot of yourselves and your trainees as well around the world. John, I think, said these problems very eloquently around, reduction in hours affecting all of us as trainees. We're not getting enough experience in the operating room, we think. There's a much bigger emphasis now on service as opposed to training. Surgery itself has changed. When I was in medical school learning, reading up about hernia repairs, it was all about suture, shoulder repairs. By the time I stepped out of training, I had to know my suture repair, my Liechtenstein repair, my TAP repair, my TEP repair. They were doing robotics, So the whole spectrum of surgery has completely changed for a trainee as well. And the curriculum and the way in which we are trained hasn't quite caught up with that yet. One of the best things about being involved with touch surgery is the sort of people that you get to meet. And I got a really great quote out of Mr. Ian Ritchie, who's one of the past presidents of the Royal College of Surgeons of Edinburgh. And he was saying to me that, Andre, I've got 30 years of surgical experience, but I can't really say that I've ever been trained to be a surgeon. And I think that struck home a lot with myself and probably a lot with some of you as well. So I guess this is kind of where it starts. I mean, I've been asked today to talk about surgical simulation and our approach to it. And I kind of want to take you through the journey of how we came to do what we do. And it already starts here in the operating room. As a surgical resident, this is really where we want to be. This is the center of our entire training experience. It can be very high pressure. There are lots of people running around. There are beeps going off all over the place. Sometimes people shouting at you to hurry up and so on. Sometimes it might not be the best place to really learn your craft. And at the center of that, don't forget, you've got a patient, right? It's all around patient safety. And I think we're all here today because we realize that, no matter what we decide here today, how we decide to take training forward, really it comes down to that individual patient, all of those patients that we're going to treat as surgeons and as physicians. And we've really got to take a step back and look at what are we doing in our training systems to really make sure that the patient remains at the center of it. And if you look at other professions where people rely on high performance, right? You'll have heard these analogies before, I'm sure, but you have professional athletes, pilots, professional musicians. You look at them, how did they learn and train to perform? Because we shouldn't sugarcoat it. When we're in the operating room, we are performing. We call it training, we call it service, but what we're doing is performing a task. And for that patient on the table, that's going to be the most important performance that you've ever done in your life. And we have to remember that. None of these other professions will tell you that they learned how to do something by performing in their respective arenas. You know, an athlete's never going to tell you, hey, I learned how to perform by running in the Olympics. That's right, it doesn't happen. A musician's never going to say, I learned how to play the violin by giving concerts. You know, a pilot probably shouldn't say that I learned how to fly by actually getting in the air. You know, all of these other professions, they get their 50,000 hours of practice not in the arenas that they perform in, but outside of those arenas. But why is surgery any different? Because as a resident, if you ask me where do I train and where do I learn, I'll tell you it's in the operating room on a patient. And I don't really think that that's really the right way to move forward. And so when we started touch surgery, we really started to look at, you know, what are the elements of surgical performance? You know, what can we help? What can we help with? And if you look at high-skilled professions, you know, there are a number of different ways to kind of split up those skills. And in surgery, like all of these others, you can divide them into technical skills and cognitive skills, right? So I don't know if any of you are musicians, but you know, when I used to play the violin, yes, you have to learn your fingering and your bow and so on, but then a huge part of it was also, well, go away and read the music, understand the music, plan what you're going to do at various points in the score and so on and so forth. And in surgery, I kind of feel like it should be the same. A lot of people, you know, train obsessively on how to tie knots and how to use laparoscopic equipment in general surgery and so on. But I don't really feel that enough of us, especially during training, spend enough time thinking about that cognitive component of surgery and making sure that you're mentally prepared to be at your best when you step into the operating room. You know, do you really know that you understand all the steps of an operation, that you understand all the critical decision points, that you know in advance what you should be doing as opposed to just reacting when you're there? And so when we looked around, I guess, the state of surgical training and some of the tools that were out there, we realized that, you know, there's a lot of work being done on technical skill at the moment. You know, there are some very clever companies with some very clever bits of hardware with haptic feedback and so on that are doing some great things. But there's not really many people looking at that cognitive aspect of surgery. And that's really where we decided to spend most of our time looking at. And that's how we came up with the concept of touch surgery. It's really digital cognitive surgical training. It focuses on, you know, I guess, brain training for surgeons, if you kind of want to put it that way. And I'm going to spend a bit of time now telling you a bit more about the platform. So, as you can see here, what we do is we focus on that decision-making aspect. It's about understanding the steps of an operation and the decision points that an expert surgeon goes through during that. We use a process called cognitive task analysis that was first developed in the military to actually interview panels of surgeons, extract their knowledge, and really break that down into key cognitive components and decisions. We then combine this with a virtual human patient, and literally, as you can see, will allow you to walk step by step through an operation. It's all provided to you on a mobile platform. You can see here on the right-hand side, what we do also is we have a testing component where we take away all of the cues and we try and get you to actually make every single decision. So you're actually now starting to select from a range of instruments and then decide what to do with that instrument on which bit of anatomy and so on. And I guess because it's a mobile platform, the great thing about it is that you can really use it wherever you want to, right? So people are using us on the bus on the way to work, in the coffee room between cases, the night before a theatre list, so they can prepare mentally before the operation. And that really gives us, I guess, a sense of scale and the ability to reach every resident on the planet, which I think is slightly different than physical simulators which are always going to be confined by physical location and so on. The previous speakers talked a lot about the importance of feedback, and I think as a resident, that was something that I really never got, right? So you get assessed twice a year, and then people, like you were saying, they ask you, so how did it go over the last year? How do you think you were? And I'll tell them, yeah, I was great. Don't worry, I did 50 appendixes, 50 appendectomies. And they're like, oh, right, great, tick. They never asked me how, they never actually assessed how well I did them. No one actually gave me any feedback on, you know what, you could have done this better, or you could have done that better, or you weren't prepared. It was just a case of I've done them in whatever way I needed to, tick. So really what we're trying to do is take advantage of the fact that we are a digital platform and we do collect a lot of data. And that data really is a map of how a resident thinks about an operation and how they make decisions during the flow of a procedure. And we can feed that back in real time, directly back to that individual, directly back to a residency program director, so that maybe for the first time, they can actually get much more transparency and an understanding of how their resident is thinking and training. They can see what parts of an operation they tend to struggle with. They can see which particular procedures they obviously need to work on. And I think this is the collection of the appropriate data and the use of that appropriately in residency programs, I think is something that we need to look at in the future. The platform itself has been available now for about 3 years. We've been slowly building up our library of content. We've got about 100 or so different procedures on the platform currently. We have over 1 million users around the world. It's available in every country. We have users in literally every country on the planet. And every month or so, we provide about 25,000 to 35,000 hours of simulation to that community. And really the best thing is that we get to work with so many individuals and so many institutions. So like I was saying, we don't go and build the content all by ourselves. As Stan was saying, that content validity wouldn't be accurate then. So we actually work with expert surgeons from a number of different institutions and societies and so on to actually help build out this curriculum to make sure that the content is suitable for the trainees that we're trying to reach. And I'm pleased to say that over the last year or so, we've started to see more and more residency programs actually seeing our platform and wanting to use it as one of the, I guess, weapons in their toolbox for residency training. So, we have, most of this is actually in orthopedics, but, we have residency program directors using us at Penn, Harvard, Wisconsin, Johns Hopkins, NYU, Cleveland, Kentucky, and so on. And over the last academic year, we've been running really in 5 major programs, signed up 165 residents, delivered over 3,000 simulation sessions for those residents, and started to get some really good feedback in terms of when the residents are using us, what they find it useful for, and obviously that's helping us to improve the way in which we deliver this education. But some really hopeful results so far. So that was kind of the platform. I wanted to spend a little bit of time going over some of the academic work that we've done, because that's often a lot of the questions that we get. We knew that when we started, it wasn't good enough just to build a nice, flashy toy, but actually we had to have some data to back up really what we were trying to show. We don't have as much expertise as the ACGME do in terms of validation, but we've been working with a number of different academic partners to try and build up a portfolio of evidence, not just for our platform, but I think really for digital training in general. And so what we tried to do was to look at, can we demonstrate that our way of teaching is valid in any sense, like the much more expensive simulators? Can we actually then demonstrate that we have some kind of educational effect? Can we compare that educational effect with other gold standard methods of training? And finally, is there any evidence really that training digitally can have an impact on your actual performance? And so this was a study done by Imperial College looking at the basic validity measures of touch surgery, so looking at face, content, and construct validity. And so for those of you who are familiar with those terms, really, obviously face and content validity is a subjective measure, which can be seen in the box in the bottom left corner, where experts assess the content to make sure that it really kind of teaches what it's meant to. These are Likert ratings out of 5, and you can see that we scored quite highly in that regard. Construct validity is the ability of a platform to actually then differentiate between different levels of surgeon in real life. So in this case, we took a cohort of novices who are final year medical students and a cohort of supposed experts who are either senior trainees or junior attendings, put them onto the platform, did our assessments, and obviously, as you can see, we're able to show that a simple tool like this can differentiate potentially between those two groups, showing some construct validity. We then repeated this study, in neurosurgery and in some hand surgery, got very similar results. We've also now done this with ophthalmology and maxillofacial surgery, and again, getting very, very similar results. So demonstrating that maybe the platform has a level of validity not only within particular simulations, but it can be applied across multiple specialties and multiple procedures. Imperial College then went on to do a study looking at, I guess, the educational benefit of the platform. This is just a graph to actually show how over time novices get better at using touch surgery over time, as you'd expect. So over repeated learning and testing cycles, 5 to 6 times, they're improving their scores significantly on the platform. And then when you compare this to actually an externally applied multiple choice question exam around that procedure, you start to see actually that novices, after using touch surgery, can bump up their cognitive understanding of a procedure really to match those of experts in a relatively short period of time. Now, obviously, this isn't real operating, it's just assessing cognitive knowledge. And one of the studies that we're doing now is to look at how quickly that knowledge decays over time, and how often you actually need to refresh to actually keep your knowledge level up at a certain level. Stanford helpfully ran a small study looking at comparing digital training with the use of textbooks and videos. They took a cohort of medical students and gave them essentially 45 minutes to an hour to learn about cardiopulmonary bypass. Gave one group the typical materials of textbooks and videos to watch, and the other group, they just gave a couple of iPads and said, go learn as much as you can, and then they gave them multiple choice question exams again. And as you can see, thankfully textbooks do work. This does prove that. But training through digital means and digital interactive means transfers knowledge, more knowledge in a shorter period of time, which we're also quite excited about. And then I guess we get on to the ultimate transfer of skills. So again, this is a small study that was run by Imperial College, looking at the transfer of skills in the context of laparoscopic surgery, so laparoscopic cholecystectomy. In this case, again, they took 3 groups of medical students. The first group on the left essentially learned how to do a laparoscopic cholecystectomy by watching videos, reading textbooks, and so on. The second group did all that, but they also underwent the FLS curriculum, which is the fundamentals of laparoscopic skills. So it's the technical training that all resident general surgeons need to go through in the US. And the final group did all that. They did the FLS training, and then they also had some brain training with touch surgery as well. They were then put onto a pig model of lap chole. Their performance was videoed and then assessed by a panel of experts. And they also had some hand tracking as well, so we put sensors on their hands so that we could understand how they moved and so on. And then what the group did was to then assess performance in some measure, looking at pure technical performance, pure cognitive performance, and then a measure of overall performance. So with the technical performance, that was based upon some previous work that they'd done that showed that expert surgeons have a better economy of motion, so they move their hands less. So a lower score is better. So on the left-hand graph there, you can see our control group in Group A Then after technical training, obviously their technical component improves. Cognitive training on top of that doesn't affect their technical movement, maybe as you'd expect. When you look at cognitive performance, that was assessed in terms of an operative checklist that each participant was assessed on. So basically what it looked at was, do these participants go through the right steps of the operation in the right order, paying attention to all the crucial learning points and so on. And as you can see, technical training on its own doesn't really impact a participant's understanding of a procedure, but the cognitive training obviously does, as you'd expect. And then finally, with global performance, that was using an externally validated system called the UBank system, where it took into account the cognitive understanding of a procedure, but also essentially looking at technical errors during that and minusing scores and so on. And so what you can see again is that a combination of the appropriate technical and cognitive training together can have a significant impact on performance. And I think that's really what we're trying to get at. It's that, a lot of people are searching for that one simulator does all approach, because I guess we look at the flight industry and we look at their simulators and it's like, wow, being in their simulator is just like being in a plane. And I think one day we will get there in surgery. I think the technology isn't there at the moment. And if you look at the way in which other highly skilled professions train, you can train individual skills separately before bringing them together in the arena of performance. So that's really what we're trying to do, just to provide an adjunct to your training programs to help trainees mentally prepare for an operation before stepping into the operating room. Thank you very much.